Hello everybody, welcome to my YouTube channel Easy Mathematics. Today in this video we are going to discuss some important theorems on power series. What is power series? That we already come to know in our previous video. Now here are some important theorems on power series. So the first theorem is, let R, which is the radius of convergence, is not equals to 0 of a power series summation an x to the power n. Then the series converges absolutely and uniformly in the closed interval a less equals to x less equals to b, where a and b are any two numbers satisfying minus r less than a less than b less than r. What does it mean? If radius of convergence is not equals to 0, that means it has some value, positive value. So that if it is so, then this series converges absolutely in the closed interval AB. These two values definitely, that means this closed interval AB entirely lies within the interval of convergence of the power series. Now one more thing, it is not only absolutely convergent but it is uniformly convergent also. We all know what is the absolute convergence of a series, but for the uniformly convergent we will at first I am giving you when a series is uniformly convergent. So for that I am just telling you, if the power series be absolutely convergent for mod x less than b, the convergence is uniform in any closed interval mod x less equals to c, where c less than b. That means if your power series is absolutely convergent within this range, then it is uniformly convergent within this interval. That's so why it is c less than b. So I hope you now have no problem that when it is uniformly convergent and absolutely convergent. So now here with an example we just disclose this thing. So given example is the power series as x plus x square by 2 square plus x cube by 3 square plus x to the power 4 by 4 square in this way. So we are verifying within the interval minus 1 to plus 1 the series is uniformly convergent or not. So for that this example we have do in our previous video also. So from there again here the an is our 1 upon n square. So accordingly if we take this ratio test, then we will find out this limiting value is 1. So the radius of convergence is minus 1 to 1, because if we take the reciprocal of this one, then also we will get it as 1. Thus the series is uniformly convergent for mod x less than 1. So that is within the open interval minus 1 to plus 1. But I told you previously that the absolute convergence means at the end point, that means at the exact value of minus 1 and the value x is equals to plus 1, this series should be convergent. Then we can say the given series is uniformly convergent within this closed interval minus 1 to plus 1. So how to verify that? So for that we need a special theorem, that is the Abel's theorem. So what is our Abel's theorem? So that is the statement for this Abel's theorem is, suppose the radius of convergence of the power series is r, and in this interval of convergence minus r to plus r, the sum of the power series is fx. That means within this interval the value of the summation is fx. That means we can write this power series is equals to fx within this interval. Now if the power series has a finite non-zero radius of convergence, that means r not equals to 0, and if it converges at x is equals to r, then limit x tends to r negative fx is equals to summation of an r to the power of n. That means in the series we just simply substitute plus r when it is convergent at x is equals to r. Okay. Now if it converges, that means it is convergence then uniformly within the interval 0 to r. If again it converges at x is equals to minus r, then what happens? Just we take the limit x tends to minus r positive. This value f x is equals to summation of a n. Here now we substitute minus r to the power n instead of x. Here instead of x we substitute minus r, and it converges uniformly in minus r to 0. Now we should try to complete this above example. In the previous example we will not so that at the end point what happened to the given series. Now after knowing this theorem we should complete this sum. So let us start again from the given example. So this one is our given example. So here fx is equals to, we can write summation x to the power n by n square in the interval -1 to +1. Now when x is equals to 1, then using Abel's theorem what we can write? We can write limit x tends to 1 negative fx is equals to summation of 1 to the power n by n square. Why it is 1 to the power n by n square? Because we just substitute instead of x the value 1. Now if we take this limiting value, so that this series becomes then 1 plus 1 by 2 square plus 1 by 3 square in this way. So which is being a p series where the p value is greater than 1 is definitely convergent. Hence the series is uniformly convergent in the interval 0 to 1. This is from the Abel's theorem we will find out. Again we should verify the same thing when x is equals to -1 using this Abel's theorem. So according to the formula we will find out limit x tends to -1 positive fx is equals to summation of n is equals to 1 to infinity -1 to the power n by n square. So this series means it is -1 plus 1 by 2 square minus 1 by 3 square plus 1 by 4 square in this way, which is an alternating series, and by Leibniz test we find that it is convergent. Hence the series is uniformly convergent in the interval -1 to 0. Therefore we can say the given series is uniformly convergent in the closed interval -1 comma +1. I hope you understand what is the Abel's theorem. So Abel's theorem is very important for the power series. Now let us do two more theorems on the power series. These both the theorems are again very important. So the third theorem is a power series can be differentiated and integrated term by term on any closed interval AB if this AB interval lies entirely within the interval of convergence. What it says, if it is a power series, then we can differentiate the entire series term by term. Not only differentiate, we can integrate also the given series term by term. One more theorem is, if R is the radius of convergence of a power series, then the radii of convergence of the power series summation n a n x to the power n and summation a n by n x to the power n plus 1. Let me tell you at first that what are these two series and how we will find out. Our given power series is summation a n x to the power n. If we do the term by term differentiation, then we will find out it as n a n x to the power n minus 1, and accordingly we will find out this series. Similarly, if we integrate this one term by term accordingly, we will find out it is as a n x to the power n plus 1 divided by n plus 1. So just look, here it is. So this one is the, definitely it is n plus 1. So this one is our, after integration we will find out so. After getting this one, we can say that the R for both the series, the radius of convergence remains same. That means in the given power series, the radius of convergence is R. In the series this one and this one, in both the radius of convergence remains same. Not only that, the interval of convergence also same in both the series. So that at the point x is equals to plus minus r, the convergency we should determine by using the Abel's theorem. So just like the previous one, that means the power series given, power series means it is always possible to differentiate and integrate the entire series term by term. After integrating whatever the series we will find out, for that series also we will get the same interval of convergence and same radius of convergence as the given power series. And at the interval of convergence, if you will find out it is as minus r, then at this end point, it is, if we want to verify the given series is convergent or not, for that we take the help of Abel's theorem. So, I hope you understand what is this derivation and integration for the power series. Let us do few examples to understand these two theorems better. So, now the first example is given: sin x is equals to x minus x cube by 3 factorial plus x to the power 5 by 5 factorial minus x to the power 7 by 7 factorial in this way. We are supposed to determine the power series representation of cos x. Also find out the convergency, find out the interval of convergence. Given series sin x, this one which is a power series, we are supposed to find out the series cos x and also the interval of convergence. So, let us see how to find it out. So, given series is this one sin x. From here, an is what? This is minus 1 to the power n minus 1 into 1 by 2n minus 1 its factorial. So, according to the ratio test, we will find out that this limiting value is 0 as n tends to infinity. So, by ratio test, we can say the radius of convergence should be infinity. We will find out the limiting value is 0. That means radius of convergence is definitely 1 by 0, that is infinity. Therefore, the power series converges for all values of x, so that it is everywhere convergent series. Now, what to do? We differentiate the given series term by term within the range of minus infinity to plus infinity, because it is everywhere convergent. So, if we differentiate this one term by term, then after differentiating this one, we will find out sin x, its derivative is cos x, its derivative is 1. Then it is x to the power 3 means 3x square by 3 factorial. So, 3 and 3, this 3 cancel, then we will find out x square by 2 factorial. Similarly, we will find out from here it is x to the power 4 by 4 factorial after differentiation. It is x to the power 6 by 6 factorial, and likewise. So, after differentiating the entire thing, we will find out cos x is equals to 1 minus x square by 2 factorial plus x to the power 4 by 4 factorial minus x to the power 6 by 6 factorial in this way, which is the required series. Not only by differentiation, we can get the required series by integration also. But remember, whenever we integrate the series term by term, we will do the range. That means our range of x is definitely from minus infinity to plus infinity. So, integration should be taken in between 0 to x, so that x, if it is minus infinity or plus infinity, then we can integrate actually. So, if we integrate the given series in between the range a to x, then what we will find out? Sin x is given. So, its integration is minus cos x. So, its range is 0 to x. Accordingly, the next term, first term is x, its integration is x square by 2. Second term in the given series is x cube by 3 factorial. So, its integration is x to the power 4 by 4. So, 3 factorial into 4 means 4 factorial. So, that we will get this one. Now, if we substitute this range of the integration, then we will find out from here it is 1 minus cos x is equals to this entire thing. So, this cos x, if we just keep in this side and 1 we will take in this side, and then we take the minus common and cancel out, then we will find out this one, which is same as the previous. So, the above is required power series expansion of the cos x, and definitely its interval of convergence is minus infinity to plus infinity according to the theorem. Now, one more example. This one is again a very important example. So, find the power series for log of 1 plus x and use Abel's theorem to show that 1 minus 1 by 2 plus 1 by 3 minus 1 by 4, this infinite series equals to log 2. So, how to proceed? At first, let us take the derivation of this log 1 plus x. So, if we take the derivative of this one, then its derivative value is 1 divided by 1 plus x. So, 1 by 1 plus x means it is 1 plus x to the power minus 1, and its expansion is 1 minus x plus x square minus x cube, that we know. So, that one is nothing but a power series, and its summation form is this one. So, if we apply the ratio test here, then we will find out this limiting value is as n tends to infinity is mod x, that means 1 actually. So, the series is absolutely convergent for mod x less than 1. So at the end point what happened? That means when x is equals to plus 1, the series becomes 1 minus 1 plus 1 minus 1. So this one is a oscillatory series. And when x is equals to minus 1, the series becomes all positive. So it is a divergent series. Hence, we can say the interval of convergence is mod x less than 1 only. At the end point, the given series does not convergent. So now we integrate this series in the open interval minus 1 to plus 1, where x ranges from 0 to x. And after this integration, we will get here x, that means this integration for we will get it is x minus x square by 2 plus x cube by 3 minus x to the power 4 by 4. So this integration means it is what? It is definitely log of 1 plus x, and one thing we will find out, which is minus of log 0 actually, log not 0, log of 1 plus x, instead of x we substitute 0, so log of 1, so log of 1 always is 0. So that the series we will find out log of 1 plus x is equals to x minus x square by 2 plus x cube by 3 minus x to the power 4 by 4, this one, which is our required series. Now at the x is equals to 1, what happens? So if in the above series we substitute x is equals to 1, then we will find out this series, which is an alternating series, and by Leibniz theorem it is convergent, that we know. So hence log of 1 plus x represents a left continuous function. So that at the point x is equals to 1, when we apply the Abel's theorem, that means when we take the limit x tends to x minus, that time what we will get? Here the left hand side it is log of 1 plus x. So according to this limiting value, we will find out this value is 2. So that one is definitely is equals to this one, so which is our required proof. So hence the proof. So in this way we can do all the sums for the power series. These type of sums, that means where the differentiation and integration should be applicable in the power series, and after that we get the result, that type of various sums we have in our different books. So from there I am just giving you 3 more questions for your practice purpose. So that is your do by yourself question. So here only 3 questions are given for you. So the first question is, obtain the power series for 1 plus x to the power minus 2 and 1 plus x to the power minus 3. Nothing else is given. You are supposed to find out the power series for these two using the power series. Next question is integration 0 to 1 log of 1 plus x by x dx, that one is equals to 1 minus 1 by 2 square plus 1 by 3 square minus 1 by 4 square plus this one you are supposed to show. Log of 1 plus x, this series already you know how to calculate. Now you find out this integration value. And the final one more question is, find out the power series for tan inverse x, and hence find out the value pi by 4 from this derived series. Okay, so these are the 3 questions for you. I hope you can able to answer all those and give your answer in the message box of this video. So that's all for the power series. I hope you enjoy the video, and in the next video we are going to do some more power series. These are the special type of series which you already know. These are the exponential series, logarithmic series, trigonometric series, inverse trigonometric series, like that. Okay, so till that, thank you all and have a nice day.